Hey again, today we're looking at exponential growth functions. So we've been dealing with exponentials a little bit, and we've been looking at graphs of exponentials. And we know that this is our basic graph of an exponential function. So b is our base number, of course. And what we talked about is that if b is bigger than 1, we know it's going to be a growth function. If b is between 0 and 1, it's going to be a decay. So again, growth means it's getting bigger as we go. Decay meaning it's getting smaller as we go. So what we're going to look at today specifically is just growth functions and kind of how they apply to some different models, so some real life examples. So we got a couple things that we're going to look at. So first of all, what we have right here is just our basic growth model. So we can use this for things that are happening just kind of naturally, whatever, populations, things like that. So A is going to be, well, we said our y-intercept before. In this case, it's going to be our starting value. R is our rate, and T stands for time. And what we can also look at, okay, is this idea of compound interest. So in a lot of things, car loans, mortgages, credit cards, student loans, things like this, you have an interest rate, but it's compounded not just annually, it's monthly or weekly or quarterly or daily or continuously. So that's where we throw in this extra value of n. So again, to recap here, A is going to be our initial amount. Okay, so this is what you're starting with, the cost, the population, the value, the amount of the loan, whatever this is. R, of course, is going to be our interest rate, and then this is a percentage, which you need to turn into a decimal. Okay, N is the number, okay, of compound or computations per year. Okay, so this is quarterly, monthly, daily, whatever it is, and then T is going to be whatever your time is. Usually it's in years, but it's going to be based on whatever your growth rate is. So if you're growing at a rate of 5% per day or per hour, well then that's what your T needs to be. If it's years, then T is in years, and so on and so forth. All right, let's do some examples. So first one here, it says you purchase a brand new car for $7,500. You get a loan for 5 years at 5.6%. Okay, this doesn't say anything about how often it's compounded, so we can use our basic equation, which again, if we look at it, that's kind of this one here, right? So we have y equals, it was a times 1 plus r to the t power. All right, so we'd have y equals a, our initial amount was 7,500, that's what we spent, and then our rate, or then what's in the parentheses, is 1 plus our rate, but I need to convert my percentage to a decimal, so 0.056, and then this is going to be to the t power. So what we're computing here, right, would be the total cost of our loan with the interest over the amount of time. So if we simplify, this would be 7,500 times 1.056 to the 5th power. And plugging that into our calculator, we end up with $9,848.74. So that means that this $7,500 purchase price with our interest is going to cost us this much total over the life of the loan. Let's look at another one now in terms of compounding. Okay, so here, right, we're investing $400, so $400 is going to be our initial amount. Our rate is 5.5%, or as a decimal, we'd convert that to this. Now it tells us we're compounded monthly, so now we have an n value. All right, so our n value, okay, is how many times per year is monthly? Well, there's 12 months in a year, so n is 12. And then it's asking how much would this be worth after 8 years. All right, so we set this up in our calculator. All right, so we do 400 times 1 plus our rate over n, all to the n times t power. Okay, so, I mean, we could simplify as we go here. All right, so we know we're going to have 400 times, if I simplify in the parentheses, okay, I have 1.00458, and then 12 times 8, of course, is 96. Then I end up with a value of $620.46. All right, we'll look at one last example here. Okay, and here it says you're given $1,000 to invest in your retirement account, drawing 7% interest, compounded quarterly. How much will this be worth when you retire? So we're assuming you're going to retire at age 67. Okay? So you need to figure out how many years until you turn 67. We're given an A of 1,000. We're given an interest rate of 7%, so 0.07. And then N is quarterly. Quarterly is 4 times per year. So go ahead and pause your video and try this one on your own. All right, so assuming that it's about 52 years until you turn 67, all right, we plug up, set up our value, or plug our stuff in your equation, set this up, and if we calculate that, we end up with almost $37,000. So this means that if you were to put $1,000 away today and not touch it, when you retire, that's going to be worth almost $37,000.